Alright, so let's prove completing the square. The technique completing the square. So, if you have a quadratic equation in one variable, let's say x squared plus bx plus c equals 0, and you take that, you subtract b to both, or c to both sides, you get x squared plus bx equals negative c. Because when you complete the square, you want it to do it to these two terms, the terms with the x in it, or the terms that can be interpreted as squares or rectangles. Like, for example, this x squared here, we can look at this geometrically and as a square. That's a square with right angles with length x and height at x. So the area of this square is x squared. So next what we can look at is this bx here. So notice again that it's something times something else. So we can interpret that as an area as well. So we can say that this is length x, the same length as this. Similarly, here it is as well. X. And this here is length b. And this here is length b. So if we take this rectangle with the area bx, we chop it in two, cut it in half, what we'll get is two smaller rectangles with top length is still x, and this length will be b over 2. And this will be x. This will be b over 2. And we'll have another one with the same dimensions. B over 2. B over 2. Okay. So now, let's move this square down here, and we'll draw it bigger because it's probably hard to see this. So this is x, area x squared, and this is also x. And so we'll take these, because this is length x, this side here, and this is also length x, we can take it and we can put it here like this. Let's say that this length is b over 2, and this length is still x, and it's still b over 2, and then the area of this is b over 2x. Similarly, we can take this one. Notice how this is length x, this side right here, and we can match that up with this side right here that is length x, and we can drop it down like that and put it there, and we'll have this length, which will be b over 2 as it was up here. This length will be x. This area will also be b over 2x. So now, if you think about the name of the technique, completing the square, here we're going to complete the square. Quite literally, we're going to take this and go like this. And we know that this length, this side, is going to be b over 2 because the length this side is b over 2. So we'll call that b over 2. And similarly, we know that this side is also b over 2 because this side is length b over 2. Meaning the area of this little square we just made in here inside the big square will be b over 2 squared. So now from here, we know that the area, if we add up the area of these four squares, well, this square and these rectangles, well, this square, and these rectangles, we will get the same thing as if we just multiplied this length this side by this side. So let's do that. So we have x squared, which is here, plus b over 2x, which is there, plus another b over 2x, which is here, plus b over 2 squared, which is this one, equals the length of this side times the length of this side, which we can write as x plus b over 2, all of it squared, right? Because it's x plus b over 2 multiplied by itself, so x plus b over 2 times x plus b over 2, and we can write that as x plus b over 2 squared. So on this side we can simplify a little further, right? Because we have 1b over 2x and we have 2b over 2x, so we can write that as x squared plus 2 b over 2x plus b over 2 squared equals x plus b over 2 squared. And this can simplify. We multiply the 2 by the b over 2, because this is really 2 over 1, so we just, when we multiply fractions, we multiply across. So we get x squared and plus bx, right? Because 2 divided by 2 is 1. And 1 times b is b, because 1 is our multiplicative identity. And then plus b over 2 squared equals x plus b over 2 squared. And now that's completing the square, because we find that this is equal to that.